to the third, so we have a function x to the third minus, of course I looked at the next one, minus 144 x minus 140. So this is negative 3. Let me check again. X to the third, yes, minus 3x squared minus 144 x and minus 140. Again, we selected a polynomial function. I will have to start with a domain, but that is always easy because the domain of all polynomial functions is all real numbers. So I'll get my chart or the table going. This is so important to understand that this table will summarize all the information, everything you need to graph. Everything will be in there. So I start with the domain. I have to have 0 in the table. When I plug in 0, what do I get? Thank you. Perfect. So now I need to determine the limits at infinity. So you understand what I'm doing. I'm trying to fill everything in here that I can find about the function from the function itself. X and Y intercepts and limits. There's really nothing else. So I will find the limit from the function as x approaches negative infinity and the limit from the function as x approaches infinity. So let's look at the polynomial function. If you want to evaluate it at x equals 2, you will plug in everywhere x is. You will replace by 2, correct? Agreed? But now I'm interested to know what happens when x decreases without bound. Huge negative number. Which of these 4 terms I should look at? Which one is the most powerful when we talk about infinities? Positive or negative, it doesn't matter. Which one is the most powerful at infinity? Right, that's the most powerful. The rest are too small to mention. They will not have any effect on the answer. So x cubed. Where does x cubed go when x approaches negative infinity? And that's the answer. Negative? Of course. The same concept. So this is, do not confuse with, this is not x approaches 3, in which all terms have value. This is at huge positive or negative. The last 3 terms mean nothing. What about this one? That's it. Now, in order to determine the x-intercepts, I have a problem with this function. I don't have algebra. It will not help us. So I can leave that alone for a minute. We have to put in the graphing calculator to find the x-intercepts. So now this is a cubic function. I know one thing, that it looks like this. It's coming from negative, I know that, and it goes to positive. So there are 2 options, only 2 options for crossing the x-axis. 1, and just 1, or 3. I don't know which one it is. Okay. I do have a calculator, which I always thought is the best ever. It's a TI-86. It has a feature that no other calculator has. It's called poly feature, polynomial. So if I just simply go to polynomial, don't waste your time, it's not in any calculator, but 86. And I put degree 3, and I put these coefficients, 1, negative 3, negative 144, and negative 140, and I click on solve. This is the only calculator that will give me the solutions. So the solutions are 14, negative 10, and negative 1. So I'm going to copy them for now. And we can do this with any calculator. So for now, I have 14, negative 10, and negative 1. But we don't have algebra for this. I can't factor this. It happens that it's factorable. Obviously, it's x plus 10, x plus 1, and x minus 14. But I would have never known this. So this is x plus 10 times x plus 1 times x minus 14. I would have had no idea. There are some ways, some algebraic ways in which you add and you subtract terms and stuff. So no, we don't need to do that. Okay, good. So this is all I needed. There is nothing else I can find. Now I move on to the first derivative. So then f prime is 3x squared minus 6x minus 144. Well, this is quadratic. I have no problems here. I can set it equal to 0. First of all, I'll divide by 3, obviously, or factor out 3 first for everyone to see. So this is x squared minus 2x, and minus, is it 48?
Yeah.
So then this I can still factor into x minus 8 and x plus 6. And it cannot be easier at this point. I will set it equal to 0 in order to find critical numbers. It will always be defined. It's a polynomial function. But there are two critical numbers coming from f prime of x being 0. And one of them equals 8, and the other one negative 6. So I have to insert negative 6 here and 8 here and put 0 for the derivative. To the left-hand side of negative 6, between negative 6 and 8, and to the right-hand side of 8, I have to study the sign. And this is the first derivative test. So the first derivative test means what? If the derivative is positive, the function is increasing. If the derivative is negative, the function is decreasing. If the derivative is 0 or undefined, where the function is defined, that is a critical number. Okay, so let's plug in a number. Because I have it factored, this is much easier. So when I plug in negative 10, this is negative and this is negative. Negative 10 minus 8, negative 10 plus 6. What will be the sign of the first derivative here between negative infinity and negative 6? And I used negative 10. Let's do that one more time. Negative 10 minus 8 is positive. The final answer isn't positive. And negative 10 plus 6. So what would be the sign? Right. Do we all see that? So when I plugged in negative 10 in the first derivative, I got to multiply two negative numbers, so that's why this is positive. Perfect. Now between negative 6 and 8, the easiest thing is to plug in 0, 0, 0 in this expression better than in this one. 0, 0, what do I get? That's it. So now I'm going to plug in 100. When I plug in 100, I have 100 minus 8 and 100 plus 6 with 3 in front. That's it. At this point, I stop and I say, okay, now is the time for me to identify max min and make sure that this row works well with this row. This is the moment in which I catch my mistakes. So let's do that. Oh, not yet. I have to find this number. So I plug in the function negative 6 and positive 8 in this function. So let's do that. So let's do it with a graphing calculator because we like to check anyway. Okay, so let's do that. So in y equals, let's put in x cubed minus 3x squared. Y equals x cubed minus 3x squared and minus 144x and minus 140. And I go with second, and I have to adjust this all the time. No, that's not what I meant. Sorry about that. Okay, second and table. And we said we wanted -6 and 8. -6, enter, 8, enter. And I put the numbers in there. Oh, wonderful numbers. So 400 and -972. Wonderful. How I'm going to plot that, I don't know, but we'll see. We'll take a large scale. Okay, good. So now let's see if these two rows work well together. Ready? Okay, so first of all, -6, 400, what type of point will that be? -6, 400.
Important.
Right. The first derivative is positive and then negative. What type of point is -6, 400?
Max.
Exactly. Is that clear? Local max. Is that clear? First derivative is positive, then is 0, then is negative. What type of point is 8, -972? 8, -972. Local min. Okay, now let's check. You're checking row 1 with row 2. You know what I mean, the first derivative and the function. Ready? What does the function do between -infinity and 400? Is that supported by the sign? Good. Okay, what does the function do between 400 and -140?
Decreases.
Between -140 and it's supported by the sign. Between -140 and -972.
Decreases.
Supported by the sign of the first derivative. Between 972 and 0 and then to infinity, what does the function do?
Increase.
Is that supported by the sign of the first derivative?
Yes.
So far, so good. Okay, final step. I need to find the second derivative. Not from this, but of course from this. So the second derivative, which is 6x minus 6. So the second derivative is 0. 6x minus 6 equals 0 means x equals 1. I put 1 where it belongs. Of course, my table has no more room, obviously, and I have to find this value here. I'm going to go back to the graphing calculator and plug in 1 in this function. Because I have it, -284, or 6. So this is -286. Good. Now I have to study the sign of the second derivative. So can you plug in a number to the left of 1 in this expression and just tell me the sign?
Negative.
Of course. Which means this. And please plug in a number in this function, in the second derivative, to the right of 1, any number you want, and just give me the sign. So this is this. What type of point is 1, -286?
Inflection.
Yes, it's an inflection point because the second derivative is 0 and it changes sign. What does that inflection point mean? From opening downward, all of a sudden opening upward, or vice versa. Ready? We are ready to graph. I do not care for any work but the table. Nothing else matters at this point. And the table will tell me what to do every step of the way. That's it. So here it is. I really have to plan this ahead. Okay, so the smallest number is -1,000. The largest number is 400. So I'm going to go by 100. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, on the x-axis, I have negative 10 and 14. From negative 10 to 14. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Okay, ready? Coming from negative infinity, the function is increasing to negative 10 comma 0. Let's plot the points first. That's better. I have negative 10, 0. I have negative 6 comma 400. 1, 2, 3, 4, 5, 6. Negative 6 comma 400. I have negative 1 comma 0. I have 0 comma negative 140. So this is 200. This will be negative 140. I have 1 comma negative 300 roughly. So 1 comma negative 300 approximately. Then 8, 2, 4, 6, 8, negative 7, 8, 972. And then I have 14 comma 0. So I plotted all these points. Negative 10, 0. Negative 6, 400. Negative 1, 0. 0, negative 140. 1, negative 286. 8, negative 972. And 14 comma 0. And now tell me when we're ready. Are we ready? Okay. From negative infinity, increasing, crossing at negative 10, 0. Fine. Opening it downward, of course. Continue to increase till negative 6, 400, opening downward. At this point, it starts decreasing towards negative 1, 0, and continues to 0, negative 140, and continues to 1 comma negative 286, all decreasing and all opening downward. At this point, this is an inflection point. It changes concavity. It starts increasing, opening upward and also increasing. So, however, at this point it's inflection point, and then it decreases, but opening upward to the local minimum. So this is the inflection point, and now it opens up. It shouldn't be that much, that pronounced, but as you know, I have a kind of a sort of weird unit. I have 1 here, but 100 here. Okay, finally, it crosses the x-axis at 14, 0, comma 0, still increasing, going to infinity, opening upward. So as you see, we did not need the calculator just to determine the x-intercepts. So now we can go to the graphing calculator for just one moment, and we can graph this, but remember we have to make huge adjustments to the viewing window. Huge. We're not going to see anything. So x minimum, negative 10, but I'm going to make it into negative maybe 20. So we can see that intercept. Or negative 15 if you don't want to go that much. X maximum, I need at least 14, so I'm going to put 20. The scale, I'm going to say 4. Y minimum, negative 1,000. Y maximum, at least 400, if not 450, with a scale of 100. And now I can click graph. As expected, no one can see or find the inflection point here. No one, don't even try. Okay, no one can find this inflection point. Everything else is as expected. It has a maximum at negative 6. It has a minimum at positive 8. And it crosses at negative, what was that, 10 and negative, what was that? Negative 1, right? Yeah, negative 1 and then 14. So now let's apply just for 1 second, and then we'll move on to applications. So let's apply just for 1 second the second derivative test. Don't erase anything. I personally don't use the second derivative test. It's easier for me to find the derivative, the sign of the derivative, and also it's very important to me to know that these two rows from the get-go, before I get to the second derivative, that these two work well together. And I will not know unless I have the sign, right? So I don't want to wait till the second derivative to identify max min. Okay, so this is a critical number, and the second derivative is negative. What kind of point will negative 6, 400 be? So the first derivative is 0. The second derivative is negative, which means the function must look like this. What kind of point will negative 6, 400 be? Absolutely. Is that clear? The function, the shape is like this. And negative 6 is a critical number. So obviously, if this is a maximum, this must be positive and this must be negative. There is no doubt. Because otherwise, this would not be a maximum. Negative 6, 400. Are you with me? Does it make sense? Say it doesn't make sense, and I'll explain again. Is it okay? So what about this point? 8, negative 972. It's a critical number, and the function looks like this. What kind of point will that be? Minimum, which means the sign of the first derivative must be negative and positive. There's no other way.
So you're kind of just hypothetically speaking, if you skip the first derivative step, go right to the second, and then you can just look at the chart and fill it in from the second.
Yes. However, I personally don't want to wait till here because I want to make sure that these two work well together. Because then I have to go back and fix everything. So that's why I prefer to cite the sign of the first derivative, make sure that these two work together, and then when I get to the second one, I don't have to go back. I don't have to worry about finding max min. But that's the second derivative test. If you don't want to study the sign, you find the critical numbers, and you will eventually find the signs from here. But it gets a little bit complicated sometimes. What if the critical number is also an inflection point? So you have to be careful with that. So I recommend the first derivative test instead of the second one, but it's up to you. Okay, I think we are ready to move on. Let's look at a word problem on page 219. Let's look at the coughing velocity. I don't know if I want to know, but since I was so sick in December, January, maybe this will tell us something. A person coughs when a foreign object is in the windpipe. The velocity of the cough depends on the size of the object. Suppose a person has a windpipe of 20 millimeter radius. If a foreign object has a radius r in millimeters, so this is one more time, problem 62 on 219. And I copy the information. Radius r in millimeters. Velocity v in millimeters per second. Need to remove the object. Okay, so if a foreign object has a radius of this, then the velocity v needed to remove the object by a cough is given by, look at that. They found the function k and 20r squared minus r cubed for r between 0 and 20. This is r between 0 and 20, r. Where k is some positive constant. For what size object is the maximum velocity required to remove the object? So how much should r be for the max velocity? This is a typical situation. We don't have to graph or anything. That was a lot of work. But here we're given a function and we're asked, find for what x value, what x or independent variable, in this case radius. So how big should the object be in radius for the maximum velocity to happen? So I'm given a function, I'm asked to find the maximum. What do I have to find? Absolutely. So let's find the derivative. V prime of r. This is a constant. Keep it outside, don't worry about it. Inside we have 40r minus 3r squared. Agreed? So I got the derivative. Now what? What do I do with it?
You plug 20 in?
Careful. I have the derivative. What is the next step? What do I need to determine? Before I even think of max-min, I need to determine
X-intercepts.
Critical numbers. Yes, if I graph.
Okay.
But I'm not graphing. So critical numbers. How do I find the critical numbers for this function? What type of function is it? Can it have critical numbers coming from both sources?
No.
It's polynomial, so only from okay, let's review this. Critical numbers come potentially from two sources. When the derivative, which we just did,
So is 0?
or it's undefined. Can this be undefined?
No.
No, it's a polynomial. So the other possibility is
When it equals 0.
excellent. So the constant cannot be 0. So 40r minus 3r squared equals 0. Remember, descending order, no negative leading coefficient, factor simplify. Keywords. I'll multiply both sides by -1. So I have 3r squared minus 40r equals 0. And I will factor out r. So I get two critical numbers. What is the first one?
0.
Excellent. R equals 0. What is the second one?
40 over 3.
40 over 3. Do we agree? Both are in millimeters. So now I'm saying both give a minimum. I'm saying both give a maximum. I'm saying whatever. I have to prove it. Whatever I'm saying, I have to prove it. And here's how I prove it. R, 0, and 40 over 3, and then 20, because that's what R is, anywhere between 0 and 20. And V prime of R. This is 0, this is 0.
Is that negative 40 over 3?
I have to move -40 to the other side and divide by 3.
Okay.
Right?
Yes.
Good. So, now, this is the first derivative. Let's say we plug in, give me a number, between 0 and 40 over 3. 1. Okay. 40 minus 3, sine.
2.
So 40 minus 3, sine.
Positive.
On the other side, let's say we plug in 20. 40 times 20, 800. 20 squared is 400 times -3 is -1200. So what is the sign on the other side?
Negative.
So, what can you say about 40 over 3? It's the radius of the object that we swallow is
The maximum velocity.
is 40 over 3.
Right.
Then we have to cough because of, according to the diameter of the pipe, right? We have to cough at the speed of I don't know, but it's going to be the maximum when what we swallow is 40 over 3 millimeters. So this is guaranteed to give a maximum velocity. The function is increasing and then decreasing. The first derivative is positive, and then it's 0 for the peak and negative. Now, if I want to determine the velocity, that is the maximum velocity, what do I need to do? I want to find the maximum velocity.
So you plug that in.
Of course, v of 40 over 3. However, I can determine it. Why? Because I'm missing this. But I just wanted to make sure that we know how to determine it. It's not even asking us to determine it. But you understand why by finding the critical numbers is not sufficient. Critical numbers do not tell me whether there is a max or a min. The sign of the derivative around those critical numbers will. Yes, please.
When I want to find my max velocity and plug my 40 over 3, if I could, should I plug that into my original problem or my derivative?
Not in the derivative.
My original.
Yes, remember this. Very good question. Thank you for asking. How did we find all these points? For -6, I plugged in the function.
Yeah.
For 1, I plugged in the function. For 8, I plugged in the function. Right? Not in the derivative. The derivative serves only one purpose, to find the critical number. Done. And when I want to study the sign, I would plug in some numbers just to study the sign, not because I need those points. I don't. Very good. Any questions on this? Yes, Maddie?
So,
Yes.
the question is, for what size object is the maximum velocity?
Right. The size of the object is 40 divided by 3 millimeters for the maximum velocity, because here is the velocity. Better? Yes, Nicole.
Can we do a problem where we have done ones where they always are equal 0? And so because we're determined how to find the critical numbers, but can we do one that's undefined?
When the function is undefined? Yes. We had an example. You mean a word problem or just a function?
Just a function.
Yeah, we did. If you remember, we had f of x equals the square root of x, and f prime of x is 1 over 2 the square root of x. This function is defined on 0 to infinity, but this function is defined on 0 to infinity. So there is only one critical number
0.
coming from undefined, not even from being 0. This is never 0. A fraction is 0 only when the top is 0, but the top can never be 0 here. So it will be, when you set it equal to 0, you don't get anything. So there is one critical number coming from f prime being undefined when the function is defined. So x equals 0. Critical number coming from f prime of 0 undefined.
So coming from a problem that's undefined, we're only going to have a max or we're only going to have a min?
It depends. It depends on the function. I can't give a recipe. Depends on the function. You may functions like, for example, we just saw this one, right? That had a local max. It had a local min. Can have any number of max min.
Yeah, one critical number.
You said so. When
No, this one had 2 critical numbers.
the one that
So when
Oh, this one. Yes.
when it's undefined, will we only get one critical number?
No.
Okay.
No. No. So, for example, we can have a situation in which, I have to think about an example, but we can have a situation in which the function is defined at 2 values, but the derivative is not.
Okay.
It's very possible.
Okay.
Yes. Okay, so the next section deals with rational functions, the whole spiel that we learned in the previous class, but of course not without derivatives and without studying the signs and so on and so forth. So this is 2.3, rational functions. Rational functions. Rational functions are more involved than the polynomial functions. And the reason is that they have horizontal asymptotes, they have vertical asymptotes, or slant asymptotes. So they're more complex than polynomial or exponential for that matter. Okay, so let's choose an example if you'd like to choose. And we'll show the exact same thing. No news, just some additional information about asymptotes. So on page 231, can we start with 44? F of x equals x minus 2 over x plus 1. This is a typical, what I like to call type 1 rational function. Not difficult at all to work with. Okay. Of course, we are asked to graph. We will go through the same steps, domain, everything. So what is the first step then? It must be domain. So negative infinity to negative 1, union. We agree? Negative 1 to infinity. So let's get the table started. F prime, f of x, and f double prime. So here's what we do. Put negative 1 and of course 0 and do this. What does this mean? Undefined, correct. If the function is undefined, of course the derivatives will be undefined. No question about that. Very good. So now I have to find this, 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 and potentially x-intercepts. What does this mean? The limit at negative infinity, the limit at positive infinity, the y-intercept, the limits left and right of x equals negative 1. When is this function 0? When is a fraction 0? When? Exactly, very good. So I'll write f of x is 0. X minus 2 over x plus 1 is 0. It must be that x minus 2 is 0 or x equals 2. So 2 comma 0. Now let's plug in 0 in this function. 0, 0. Negative 2 over 1. How much is that?
Negative 2.
Perfect. So when x is 0, y is negative 2. Okay. Now you may remember this or not, but you don't really have to remember it. Can you tell anything about this? These two limits. It's okay if you don't remember from pre-calc or from college algebra. Oh, let's say we don't remember. Yes, Maddie?
What was the question?
Yes, I would like to determine this limit and this limit. We'll do it right now. We'll do it right now. So limit as x approaches negative infinity from x minus 2 over x plus 1. Do not look at the denominator and tell me the degree. The degree. 1, right? Degree 1. It's a linear expression, right? X minus 2 is linear. So I will factor out, since you said degree 1, I will factor out x. And you could say, wait a minute, how can you factor out x? X is not a common factor. True, it's not. But whatever I put in here, two terms, this times the first term has to give me x, and this times the second term has to give me negative 2. And then I'm okay. So x times what is x? Very good. Minus. Stay with me. 2. So x times a fraction will give us 2. Which fraction is that? 2 over? But it has to be x so I can simplify it, right? So x times 1 is x. X over 1 times 2 over x will be negative 2. Would you agree with this? So I forced a common factor. It wasn't the common factor. but I forced it up. You'll see in a moment why. Okay, very good. Now let's look at the denominator. What is the degree of the denominator?
-1.
So for all these linear, the degree is 1, right? So x plus 1 is a linear function. So the degree is 1. I will factor out the degree. So the reason I cover the denominator is because you always factor out the degree regardless of what the top or the bottom. Yes? Jess, you want to say something?
No, I just.
Okay, so if this is 3 and this is 4, you don't make a decision based on what is the degree of the other one. Degree 1, I factor out 1. Degree x. In degree 1, I factor out x. But what do we have in parentheses?
1 + 1 over x.
Do we all agree with 1 plus 1 over x? So x times 1 will give us x. X over 1 times 1 over x will give us 1. Agreed? Okay. What do you think I'm going to do next? Just look at this and say, oh, you're going to
Cancel them out.
simplify x with x. And now I'm going to think. This is so big. I have $2 and I want to divide it by everyone. When I knock to your door, how much will you get from that those $2?
2 pennies.
Nothing. I'm not going to have anything because this is huge. So this quantity approaches
0.
What about this quantity? When I divide 1 by huge, remember this is infinity. I'm not talking about 5. If x approaches 5, this is 1/5, which is not 0. But x approaches something huge, positive or negative, it doesn't matter. What does this approach?
0.
Correct. So 0, 0. So what is left?
Nothing.
Oh no, these are left. Only these approach 0. This approaches 0. This approaches 0. So the answer is 1, which means 1 here, and definitely 1 here because I did not use the sign, which means y equals 1 is a horizontal asymptote. We didn't do this in pre-calc or college algebra. I taught my students, okay, this is type 1, same degree over same degree, leading coefficient over leading coefficient. But now we can do this to find the horizontal asymptote. We did not use the sign. Positive or negative, it doesn't matter, it's still approaching 0.